Today we're going to talk about inconsistent and dependent systems of equations, and we're going to use Gaussian elimination still. So this is section 7.2, inconsistent and dependent systems. So number one is, what exactly is a system with no solution, and what does it look like? So we're going to start with systems without unique solutions. So a system with no solutions is a system where the two lines or planes never meet. Which makes sense because a system solution is either a point or an equation of the line. So let's look at what it looks like when we're using Gaussian elimination, what it means to be a system with no solution. So example one, solve. So the system it gives me is x minus y minus 2z is equal to 2. The second equation is 2x minus 3y plus 6z is equal to 5. And the third equation is 3x minus 4y plus 4z is equal to 12. So we're going to go ahead and use Gaussian elimination. We start by creating our augmented matrix. So we list the coefficients of x, 1, 2, 3. Then we list the coefficients for y, -1, -3, -4. Coefficients for z, -2, 6, 4. We separate our coefficients with our constants, and our constants are 2, 5, and 12. There's my augmented matrix. Now in order to solve this, the first left-hand corner needs to be a +1. Perfect, it's already there. So now let's go ahead and make this to a 0. In order to do that, I'm going to take row 1 and I'm going to multiply it by -2, and then we're going to add it to row 2. Let's do that scratch work right here. So that would give me -2. -2 times -1 is +2. -2 times -2 is +4. And -2 times +2 will give me -4. And then I'm going to put row 2 right below it. 2, -3, 6, and 5. Let's add these guys up. -2 and 2 cancel, leaving me with 0. 2 minus 3 is a -1. 4 and 6 will give me 10. And 5 minus 4 is 1. So this is my new row 2. My new matrix is the matrix 1, -1, -2, 2, row 2, 0, -1, 10, and 1. And then my third row, 3, -4, 4, and 12. Now I want this 3 to become a 0. The way we're going to do that is the same way we handled the 2. So I'm going to multiply row 1 by -3. This way, the 3 and the -3 can cancel. So let's multiply. -3 times 1 is -3. Negative 3 times negative 1, positive 3. Negative 3 times negative 2, positive 6. Negative 3 times positive 2 is negative 6. Then we write row 3 right below it. So 3, negative 4, positive 4, and 12. Add them up, cancel, gives us 0. 3 minus 4, 6 plus 4, and 12 minus 6. There is my new row 3. I'm going to go ahead and write my new matrix. 1, negative 1, negative 2. So row 1 and row 2 are not changing. On this, only row 3 is changing. Let's write our new row 3. 0, negative 1, 10, and 6. Now I want this negative 1 right here. I need that negative 1 to become a positive 1. So the best thing to do is to multiply it by negative 1. So if we multiply that by negative 1, my new row 2 is going to be 0, 1, negative 10, negative 1. Now I want this negative 1 to be 0. Easy. If I add these two together, they will cancel out. I don't even have to multiply by anything. So I'm going to add row 2 with row 3. Not 3 times row 3, but with row 3. So that's 0, 1, negative 10, negative 1, and row 3 right below it. And I get 0 plus 0, 1 minus 1, 10 minus 10, 6 minus 1. So let's write our new matrix, and then we'll handle that little problem in one tiny second. Row 2, 0, 1, negative 10, negative 1, 0, 0, 0, 5. So this is the end, and I know, so all my whole bottom row is all zeros. So what this means is that 0 equals 5. That's what this last row is telling me. 0 does not equal 5. This is a false statement. Because this is a false statement, we say there are no solutions. So it is possible to end up with a false statement there. When that happens, either all the planes are parallel, or they intersect, but they don't all intersect at the same place. So that is a possibility, and it does happen. Now let's look at what happens for an infinite number of solutions. Real quick, sorry. Once I know that there's no solution, we say that the solution could be the empty set, or we can call it inconsistent. Because there is no solution. Okay, now let's move on to infinite number of solutions. So if there are infinite number of solutions, this happens when two or more lines or planes intersect completely. And I don't know how any other way to explain it other than they either intersect to form a line, which is just an infinite solution, not a point. A point is a single one solution. Or the three planes lie right on top of each other, creating infinite, just like that case where you have two lines. The equations look different, but when you graph them, they actually are the exact same graph. So when we're using three variables, we talk about planes. So infinite solutions for planes can be an equation or just that they all are the exact same plane written in a different way. So let's look at example 2, and we're going to solve one and see what the solution will look like when we solve it. So I have the system 3x minus 4y plus 4z is equal to 7, and x minus y minus 2z is equal to 2, and 2x minus 3y plus 6z is equal to 5. The first step always, go ahead and create your augmented matrix. So let's list those coefficients for x. We have 3, 1, 2, negative 4, negative 1, negative 3, 4, negative 2, positive 6. Separate our constants and we get 7, 2, 5. Our first objective is to make this top left-hand corner a 1. Well, I already see that I have a 1 right here, so why don't we go ahead and switch rows 1 and row 2. Switch row 1 with row 2. When we switch row 1 and row 2, we end up with 1, negative 1, negative 2, 2, and then 3, negative 4, 4, 7, and then 2, negative 3, 6, and 5. My next objective is 3 needs to become a 0. So the way I'm going to do that is I'm going to take row 1 and I'm going to multiply it by negative 3. Then I'm going to add it to my row 2. So if I multiply row 1 by negative 3, that gives me negative 3, positive 3, positive 6, and negative 6. Write row 2 right below it, 3, negative 4, 4, 7. 3 and 3 cancel. 3 minus 4 is negative 1. 6 and 4 is 10. 7 minus 6 is 1. There is my new row 2. So my matrix is 1, negative 1, negative 2, 2. Row 2, 0, negative 1, 10, 1. And my row 3, 2, negative 3, 6, and 5. So now we want this 2 to be 0. We do the exact same thing. Negative 2 times row 1, and we're going to add it to row 3 this time because I want to cancel out that 2. So negative 2, positive 2, 4, negative 4. And we're going to add it to row 3. 2, negative 3, 6, and 5. Add them up. Negative 2's cancel, 0. 2 minus 3, negative 1. 6 and 4, 10. 5 minus 4, 1. So now let's go ahead and place that into our row 3. Now I want to go ahead and make this 1 right here a positive 1. So let's multiply that sucker by negative 1 times row 2. So row 1's not changing. Usually row 1 doesn't change after the first step unless we really made a mistake somewhere and have to fix it. So then 0 times -1, -1 times -1, 10 times -1, 1 times -1. Now I want this -1 to be 0, so we're going to go ahead and take row 2 and add it to row 3. And I'm going to do the work for this right here. So row 2 is that guy. Row 3 is this guy. Add them up. And we see we get 0 for everything. So here is my final matrix. 1, -1, -2, 2. 0, 1, -10, -1, 0, 0, 0, 0. This last row right here tells me that 0 equals 0. This is in fact a true statement, which means that this has infinite solutions. And if there's infinite solutions, we say this is a dependent system. That is it. So if you need to rewatch, stop or slow down or rewind, go ahead. But other than that, your homework is online and you can start it now.